Look closely at this water and you'll miss it. A spider no bigger than your fingernail gliding across the surface of a flooded rice field. Tonight, it will kill more crop-destroying insects than an entire tank of pesticide could manage in a week. No chemical company built this. No government funded it. It's been happening in the mud beneath farmers' boots for as long as rice has grown here. And for 40 years, those farmers waged a chemical war against the pest that was already being defeated by the very predators their sprays were quietly wiping out. By the time this story ends, you'll understand how one nation ran the largest real-world experiment in the history of pest control, staked an entire harvest on the outcome, and proved something scientists are still trying to get people to believe today. Rewind to the 1970s. Across Southeast Asia, a new strain of high-yield rice was transforming harvests, until an insect, barely the size of a grain of rice, started tearing through it. The brown planthopper didn't just eat the crop, it drained it from the inside, sucking the stems dry until entire paddies collapsed into a scorched brown ruin farmers came to call hopper burn. Governments responded the only way anyone knew how. Spray harder, spray sooner, spray more. Indonesia subsidized pesticides so aggressively that farmers stopped waiting for signs of infestation. They sprayed on a calendar, like clockwork, whether the pest had arrived or not. But here's what nobody could explain yet. The more they sprayed, the more the planthopper came back, which raised a question none of them wanted to sit with. What if the chemical itself was the reason the enemy kept returning? That's the question that pulled a young entomologist named Peter Kenmore into Indonesia's rice paddies in the late 1970s. What he found didn't just answer the question, it flipped the entire premise of pest control on its head. A rice paddy, it turns out, is never really empty. Even between plantings, decomposing plant matter in the flooded mud feeds midges and tiny detritus-eating organisms. And those organisms feed a standing army of predators that's already in place before the planthopper even lands. Wolf spiders patrolling the water's surface, mirid bugs hunting along the stems. A landmark study published in the journal Ecology in 1996 confirmed exactly what Kenmore suspected. Fields left unsprayed carried thriving predator populations that kept planthopper numbers suppressed all season long. But the sprayed fields told the opposite story. They didn't end the season with fewer pests. They ended up with more. Here's the mechanism, and it's brutally simple once you see it. Insecticide doesn't choose sides. It kills the planthopper feeding on the stem, but it also kills the wolf spider hunting that planthopper and the mirid bug feasting on its eggs. The problem is, the math isn't equal. The planthopper can rebuild its population within days. Its predators can't recover anywhere near that fast, which meant every spray a farmer trusted to protect his field was, at the very same moment, dismantling the only system capable of holding that pest down for good. Researchers at the International Rice Research Institute, known as IRRI, eventually gave this cycle a name: insecticide-induced resurgence. The chemical wasn't ending the crisis field by field, it was manufacturing the next one. By 1986, the evidence had piled up too high to ignore, and Indonesia's government made a decision no country had attempted at this scale before. Presidential Instruction Number 3 banned dozens of the insecticides most heavily used on rice, and began stripping away the subsidies that had made routine spraying almost free. This wasn't a cautious policy tweak. It was a national bet that a spider could outproduce a chemical company. And it came paired with something just as radical: farmer field schools, where growers were trained to stop spraying on instinct and start reading their fields instead. Walk the rows, count the pests, count the predators, and only act when the balance genuinely tipped. It sounds almost too simple to move an entire nation's food supply. And yet, within a few growing seasons, something happened that no chemical company had predicted, and few scientists had dared promise. Planthopper losses that had haunted Indonesian rice for over a decade began to collapse. That collapse became one of the most cited proofs in the history of agricultural science. Hard evidence that an ecosystem, left mostly alone to do its work, can outperform a chemical arsenal engineered to dominate it. The model spread. Farmer field schools were adapted across the region, training a new generation of rice growers to read a field instead of fearing it. But proof isn't the same as permanence, and that's the twist almost nobody saw coming. In the years since, researchers, including K.L. Hyong and his colleagues at IRRI, have tracked something unsettling: the same insecticide-induced resurgence pattern resurfacing in parts of Vietnam and Thailand, wherever heavy spraying crept back in and predator populations were suppressed all over again. The lesson Indonesia proved in 1986 was never really about one government banning one list of chemicals. It was about protecting a food web almost nobody thinks to look for, one built from spiders, wasps and bugs living quietly in the mud beneath their boots. 40 years ago, a government proved that a spider on the water could outkill a chemical industry. Today, in some of those same fields, the sprays are creeping back in, and so, quietly, is the pest that was never really the problem to begin with. Indonesia already answered whether nature's kill rate works. The harvest data settled that in 1986. What's left unanswered is whether we're willing to remember it, or whether we're about to spend another 40 years relearning a lesson that was already sitting in the mud.